Okay, this is the lesson 1.8, combinations of functions and composite functions. And tomorrow, when everybody's hopefully back in class, I'll be announcing our schedule for next week. Even though mid-quarter is on Wednesday, just because of a bunch of reasons. I think we will move our test to Thursday, and that will be helpful in the fact that you can, we'll have a little more time to do this 1-9 as well. And we do have that shortened hour on Tuesday. So the help session, though, I believe will still be on Wednesday of next week. And we'll kind of firm that up for sure tomorrow. So this is 1-8, combinations of functions and composite functions. We probably won't get this done today because I did give quite a bit of homework checking time. Just remember, if you have a homework key, that you return it. If you're gone today and you want to check some homework, you can come in kind of any time and do that. If you give me a heads up, I will have a key kind of ready for you. So 1-8, combinations of functions and composite functions. Does anybody still need to see that heading? Okay. So our objectives are to add, subtract, multiply, and divide functions. Those are going to be very straightforward. The only thing we have to keep in mind is if we're dividing functions, we can't have, oh, excuse me. We have to give an extra restriction in the domain because the bottom of the fraction can't be equal to 0. And the other little trickiness is subtracting functions because people tend to forget to distribute the subtraction through there. And then find the composite of one function with another and use combinations and compositions of functions to model and solve real-life problems. So the first thing is just arithmetic combinations of functions. So this is, you have two functions, you add them, you subtract them, you multiply them, or you divide them. And so this will be pretty straightforward for us. We will we'll write an example of each. I have an extra example of each. If we choose to go over those, if you feel comfortable with it, we won't, or we'll go over whatever ones you want to kind of look at. But we will write out one of kind of each as we go. And so our two functions that I'll ask that you write down right now are f of x equals 2x minus 3 and g of x equals x squared minus 1. So these are ones that the book author is just kind of going to go through with you. I thought we might as well just do them together ourselves. So if you'll write down what f of x and g of x are, then we'll add them, subtract them, multiply them, and divide them. So this makes a new function. So, for instance, if we're going to do two things, maybe in some kind of manufacturing situation, we're going to do two different things where we take whatever it is we're manufacturing or some dynamic of that, multiply by 2, subtract 3, and we also have another dynamic for that same problem that we square whatever it is and subtract 1. Instead of finding a bunch of answers for f of x and finding a bunch of answers for g of x and adding them together, we just make a new function is what happens. So you also might want to write, or you do want to write down that this is f of x plus g of x. And when I write it at first, I'm going to put each of these functions in parentheses just to offset them. So f of x is 2x minus 3 plus, and then g of x is x squared minus 1. And then really I'm just going to drop those parentheses and combine like terms. I can do that kind of all just by looking at it. X squared, I'll write it even from highest power to lowest power. X squared is the only squared power plus 2x. And then I have a minus 3 and a minus 1, so it'll be minus 4. And I'm just combining terms. Personally, I tend not to write them with the parentheses around them, and I just combine the terms as we go. So adding, people usually, are spot on with adding. Subtracting is the one we have to just be careful of. because sometimes people forget to distribute the subtraction sign. And this one you do need to write, especially g of x in parentheses. So I'll use good form. This is f of x minus g of x. And so f of x, I'll put it in parentheses, is 2x minus 3, minus g of x, which is x squared minus 1. And if I could make you never make a common mistake, I sure would do that somehow. But the problem here is people tend to subtract x squared, but then they keep the minus 1. And so we just have to remember to distribute that. So I will write kind of an intermediate step, dropping the parentheses. The beginning part is just 2x minus 3. The end part is minus x squared, and then plus 1, because it'll be minus a negative 1. And we know that, but we just have to remember to put it in practice. And I'm going to go from highest power to lowest power again, standard form. If you don't list an answer from highest power to lowest power, I don't take points off unless I've specifically said write it in standard form. So generally, if you started with the 2x here, you're fine. I just like to put things in standard form. So negative x squared plus 2x, and now it's minus 3 and plus 1, so that'll be minus 2. So just a reminder, this is the one of these that kind of is the trickiest in a way because of that. Then multiplying, we're just going to use the distributive property. These are both binomials. And notice they're unique. They're not like usual binomial factors we get, because this is 2x minus 3, but that's x squared minus 1. So when we get those four terms, when we do that process, things might or might not combine together. So f of x times g of x is just 2x minus 3 times x squared minus 1. And we'll distribute that as we go. I want to write it twice, so I think I'll just write it next to here. So I take the 2 times each of those, and that is 2x to the third minus 2x, and I'll just color code that a minute. Then I'm going to take negative 3 times each of those, and that's going to be minus 3x squared plus 3. And by all means, let me know if I make a mistake there. And then the only reason I'm writing it twice is because I want to write it in that descending order. Because you'll notice in this case, because it's x squared, a number, or excuse me, an x, a number, an x squared, and a number, our terms, there are 4 different terms that are not common terms. And so 2x to the third minus 3x squared minus 2x plus 3 will be the answer to that one. And then often the division one is the easiest just because you write it as a fraction. The only thing I will caution you about is if you get something like a radical in the bottom, you have to make it in simple radical form. And the other thing is you have to say, oh, the denominator can't be equal to 0. So you have to figure out what would be the case there. And I can't see them anymore, but here they are. And so for this one, it'll be f of x, which is 2x minus 3, over g of x, which was x squared minus 1. And hopefully you have those written somewhere. So this one doesn't need to be reduced or simplified. It's fine the way it is. The only disclaimer that we have to have is the denominator can't be equal to 0. So denominator can't be equal to 0. So we'll have to restrict the domain. X squared minus 1 can't equal 0. I'll add 1. X squared can't equal 1. What would make x squared equal to 1? What times itself equals 1? 1 or negative 1. So the real restriction we give here is x cannot equal plus or minus 1. So x cannot equal plus or minus 1. Oops. So that is the restriction of the domain. This first stuff was me kind of figuring out the restriction of the domain. So do you feel like you can add, subtract, multiply, and divide? Yes. And so then I will just ask you this question. Let me see. Domain. Okay, the domain is the set of all real numbers that are common to the two domains. And we didn't really go over that because, like, the one was linear, the domain is all real numbers. The other one's linear, the domain is all real numbers. So essentially, there were no domain issues. It was all real numbers no matter what, except for in that division one where we couldn't have the denominator equal to 0. This just kind of tells you about those functions. I don't know if you want to, write that down. I will say this on a test, if you're seeing that notation, you just have to know that it equals that. So maybe even on those ones that you just wrote, you want to write, that on the side. It's just showing the division, multiplication, subtraction, or addition in addition to that. Uh, in addition to that, I guess. Yeah. So does anybody want to see that any longer? Okay, then here's the other question. My question to you is, do you want to go over the sum and even the difference or the product or anything for this one, or it's pretty much just like those four that we just wrote down if you wrote something for yourself. The only thing is then to evaluate it when x equals 3, essentially we just go to our answer rule, and I'll just go back to these. I'm not even going to put it in, but to find f minus g of 3, we just put 3 in that new rule, right? And then we would find a value for that. So that's what's happening in those. And I'm comfortable with skipping that if you are. Just as always, if you're practicing it, that subtracted thing and you're checking your work, you'll catch if you're making that forgetting to distribute through kind of thing. And the next thing is composition of functions. They're kind of nested functions is the way I like to think of them. So this process is not commutative. So for instance, let's think of that other problem we did. When we found f of x plus g of x, right? We just added them together. If we'd have found g of x plus f of x, would it have been the exact same answer? Yes, right? They just would have been maybe mixed in a different order, and I put them in a standard order anyway, so I would have gotten the exact same thing. Composition of functions, if you find f composed with g of x, and then you find g composed with f of x, they are very different functions, usually. Depending, well, the only time they're not different is if they happen to be inverses of each other, then they're both equal to x. But composition of functions. So this is another way of putting two functions together, and it's kind of a nesting. And you can just look at this slide because we'll have a problem or two that we go up over. So if, for instance, f of x is x squared and g of x is x plus 1, the composition of f of g of x means we figure out what actually g of x, the inside function, is first, and then we find out what the outside function. So it's like in manufacturing again, maybe, if you put something in and you have to do something to it and get that out, then you take that answer and you put it in the next thing and get another answer out as you go through that. And this is denoted, and it almost looks like fog, but it really isn't fog. It's F composed with G, and that's how we read it. F composed with G, or later on G composed with F. And we have a nice little slide that kind of gives the rule. So this is the definition of the composition of two functions. The trickiest part sometimes is the domain. So the composition of the function f with the function g is f composed with g of x equals f of g of x. And I use that notation every single time I do it, pretty much, as we go through. And so then the tricky part here is the domain of f composed with g is the set of all x that are in the domain of g so that the answer, the range of G, is in the domain of F. And a lot of times there's no issue there, but the deal is if there's a restriction of G, we're not using maybe every number that F could use. I'll say it that way. And so we have to kind of think about that restriction. So do write yourself a little note about this. So the domain is going to be the set of all X that are in the domain of G. So know that you start by looking at G, that inside or second function. And these are the range values or the Y values from G, and they have to work the in the F rule. And I'm going to slide that up just so that you can see that little picture, which may or may not be good for you. So then, just kind of looking at this picture, I don't know that it's worth drawing, but, just to kind of give you a sense. So even though you say the F first, it's F composed with G of X, you actually look at what works in the domain of G. And so if you do it like step by step, you put those X values in G and you get the answer for G, or the range. And then you take those answers and you put them in F, and then you get a new answer again. And so, the short distances from there to there. So we kind of have to think about where these pools of numbers are, these domains and ranges as we go. So you ready to try a couple? Yeah. All right. And so I have this little strategy I used today just because I had time while you were working. And so I made my slides so that I can do A, B, and C kind of on separate slides, and I put the rule up there. And so this is just my reminder to myself that I don't have to do them all on this one slide, just so that I can put them a little bit separated out. So do write down these two rules, f of x and g of x, so that you have those in front of you. So f of x is linear, g of x is quadratic. So, keep in mind when you put things in and you get things out, you don't necessarily get out every number. So let's just kind of in our heads think about this. What is the domain of 4 minus x squared? It's a parabola. I think it looks like that, right? And it's shifted up 4 after it's reflected. And so the domain is all real numbers, right? Because it's the parabola shape. And so we can use any real numbers. When we put it in there, we'll get real numbers. We won't get every real number, but we'll just get answer numbers. And then any number that we would get out of that, should it work in there? Yeah, right, because no matter what we get here, it'll work in there. So there's no restrictions or anything with the domain for this one. So the first thing we're going to do is f composed with g of x. And I generally write that that's f of g of x. And I'll color code this a little bit. So it's g of x that has to go right in there. And that's this piece right here. And so then the next time I write it, I write the black stuff, f of, and then I'm going to put g of x in here, 4 minus x squared. And so, oops, and so it's kind of a nested situation as I look at that. and just kind of write that. And actually, for some reason, I go over and then I go down. And so then now I'm going to take this F rule and I'm going to put all that right here in place of that X. So I'm going to write that is equal to X plus 2. In place of that X, I'm going to put 4 minus X squared. So kind of look at it, make sure you can kind of still see those two rules. So you've got 4 minus X here, plus 2 is the X plus 2. And then in this one, it's just a matter of cleaning that up. And so what is that? 4 and 2 we can add together. So we get 6 minus X squared, or negative X squared plus 6. So F composed with G of X is equal to this new rule. So instead of saying, oh my gosh, that scared me. Oh, because I didn't start at the beginning of the hour. I'm like, wow. Okay, so that's where we left off, and we'll compose it the other way tomorrow.